Assalamualaikum students. Today we will do theorem 10.1.2. In the statement that is given in front of you, that is, if two angles of a triangle are congruent, then the side opposite to them are also congruent. This theorem is very easy. We will see we have only one triangle, and in one triangle we are talking about here the two angles, and the two angles that are given in front of you, that is B and C. If we are taking these two triangles, so what does it mean? These two triangles are congruent, then the side opposite to these two triangles are also congruent. What does it mean? For example, as you know, in a triangle, and we will talk about the isosceles triangle. For example, these two triangles are congruent, means these two triangles are equal. In maths we use term congruency for equal, so we can say if these two triangles are equal, then what does it mean? The sides are also equal. So in this theorem we will going to prove if two angles of a triangle are congruent, then the side opposite to them are also congruent. So by taking a two triangle, but how we are going to take a true triangle? We are going to write it down. The first of all, given. What is given? I told you you need to write down the given with a statement. When you will see the statement right after the statement if and till this comma. If two angles of a triangle are congruent, means in triangle ABC, the original triangle is triangle ABC. So what is it? In two, if two angles of a triangle are congruent, means two angles, like if you are going to see this triangle ABC like this is, then what is it? Angle B is congruent to angle C. This is your given statement. What is this? This is your given statement, and you can see in this given statement we have only this thing given, that is in triangle ABC, triangle B is congruent to angle C. When we were doing the previous theorem, I told you then after this, then the side opposite to them are also congruent. It should be written under the heading of to prove. So I am writing over here to prove. So what I'll write it down to prove. So what we will do, you can see I'll write it down like this is AB is congruent to AC. They have told in the statement the side opposite to them. The side opposite to angle B is AC, and the side opposite to angle C, that is AB. So these are the sides that we need to show the congruency, or we need to show these two sides are equal. Now coming back towards the construction, so I'm writing over here on the right side, that is construction. Yes, what is in construction? Construction, it will come in construction that we will draw the angle bisector of A. You can see angle bisector of A means we are going to bisect this angle into two equal parts. एंगल बाइसेक्ट का मतलब ये होता है कि आप इसको दो इक्वल पार्ट्स में डिवाइड कर दें. सो आई एम गोइंग टू ड्रॉ द बाइसेक्टर ऑफ एंगल. सो ओवर हेयर आई विल राइट ड्रॉ बाइसेक्टर ऑफ एंगल ए. ठीक है जी, एंगल ए आपने इसका बाइसेक्टर ड्रॉ कर दिया. उसके बाद बाइसेक्टर मीट कहाँ हो रहा है? मीटिंग एट BC at point D. तो आप ये भी लिख सकते हैं मीटिंग. I'll writing over here meeting BC. BC is a line, so we write the line on the BC at the point. What is the point where it meets at BC? That point is called D, and you can see from here. Okay, Now, after given, after to prove, after construction, we will come towards the proof. This is the proof that is in front of you, which I have already mentioned it over here. Now, in proof, I told you that you people have two columns. In first column, the statements, and whatever the statement you people are writing, the reasons must be in front of that. So, as I told you in the previous theorem, uh, we will take the constructed triangle. So over here in this statement we will only have the ABC triangle, but now I'll take the two constructed triangle, that is ABD and ACD. So what is this? Triangle ABD is correspondence to triangle ACD. We have two triangles and we will show the one-to-one correspondence. One-to-one correspondence means we will take, if I'll take angle B, then I'll take angle C. If I'll take angle D, then I'll take angle D. If I'll take angle A, then I'll take angle A of the other triangle. So the first thing is the very easy theorem. AL is congruent to DM. What does it means? AL means this is AL AD. This AD is congruent to AD, you can say, or you can say this is over here AL or DM. Why I am writing AL DM? Because you can see this is over here in one triangle, you can say L, or you can say another triangle, you can say this point M. So you can write it down like this: AD congruent to AD. Why? Because it is common. Clear? Then what is it? A angle B is congruent to angle C. Why? Because it was given in over here and given. You can see the reason that is written in front of this. This is given. So the next thing is angle BAD and angle CAD. This is again congruent. Why? Because of the construction. We know the angle bisector of A. So these two, when we are going to draw the angle bisector, then these two triangles must be equal. So we can say BAD and CAD. These two triangles are congruent. As I told you, when the two sides or two angles, or for example two sides and one angle, two angles and one side are congruent, then we can use the side angle or side angle side postulate. Over here what we did, see what we did, this is side, this is angle, this is angle. So what we did, we did side angle angle postulate. This is side, this is angle, this is angle. Side angle angle postulate, and we are showing the congruency of these two triangle. Triangle ABD is congruent to triangle ACD. With the help of the postulate, what is postulate? You can see from here, side side angle angle, again side angle angle postulate. So when the two triangles are congruent, what we will show, hence, or you can say conclude, so last in last, so AB is congruent to AC. Now we can say if this triangle 1 is congruent to triangle 2, so all three sides are equal, all three angles are equal. So angle, after this the sides are also congruent. AB is congruent to AC. So this was the proof that we need to show it. AB is congruent to AC. I hope the statements are clear. What we need to do, given, then to prove, then the construction, then proof, and the first and the main thing is the figure. Clear? I hope there isn't any ambiguity, because this theorem is very easy as compared to the previous one. If you have still any query, you can ask. Thank you, students.